letters, letters.
very simple. என்னது பெண்ணா?
ஆமாங்க, எழுதவே இல்லை. ரொம்ப பிடிச்சிருச்சு.
எழுதி பாருங்க.
Children, now, good morning, children. Now we are going to analyze the characteristics of the compounds of alkaline earth metals. First of all, you should know what is alkaline earth metals. Second name families are called alkaline earth metals. This is that having NS2 electronic configurations. And which are all elements which are belonging to this family of beryllium, magnesium, calcium, strontium, barium, and radium. These are all the elements which are belonging to this family. So generally, which all elements are known as alkaline earth metals. The secondary families are called alkaline earth metals. This alkaline earth metals are generally that we are going to study about the characteristics of compounds. What are the compounds of alkaline earth metals? Compounds. What are the compounds? Generally, that you know the compounds are nothing but oxides. The compounds are nothing but oxides, hydroxides, then peroxides, oxides and peroxides, then hydroxides, then chlorides, halides, chlorides, then sulfates, nitrates, carbonates, nitrates. Apart from that, there are the two compounds of this family which we are going to study about specially. That is, namely, we can see that what is sulfates. The sulfates are in variety. That is gypsum and plaster of Paris. Gypsum and plaster of Paris. This is the compounds which we are going to study about, and especially we are going to study about the oxides. That is, calcium oxide is called quicklime. This is called quicklime. And we are going to study about hydroxides, calcium hydroxide. Along with this calcium hydroxide, we are going to study about there is bleaching powder. You know that calcium oxychloride, bleaching powder. This is calcium oxychloride. Bleaching powder. We are going to study about these are all the compounds of that secondary families. Especially we are going to study about these calcium compounds. Calcium compounds and beryllium compounds. Beryllium compounds. These are all the things we are going to study about now. And first of all, and we are going to study about these oxides, or nothing but we can study it as monoxides, monoxides and peroxides. These are all the things we have studied already in the last session. Monoxides are nothing but beryllium oxide, magnesium oxide, calcium oxide, that you know, calcium oxide. Peroxides are nothing but barium peroxide. You take it now, BaO2. Actually, here the charges is 2 minus 2 plus. It is that electrically neutral. This is that compound is electrically neutral. But here the neutrality we can't find in this case of barium peroxide. In this peroxide, in this peroxide, the charge of oxygen is having -1 and a -2. In oxides, oxygen is having in oxides, that oxygen is having -2 oxygen state. In peroxides, oxygen is having -1 oxygen state. Now this is balanced. Now this is that balanced in its charges. So now you are very clear about this. What's the point here? Next we are going to study about the concept. What's the concept of there is generally these all oxides, you know that generally the oxides, the first of the series, beryllium and its oxides are covalent natures. This is the question. All, but other than that, while you are moving down the groups like magnesium oxide and calcium oxide and barium oxide, these are all the oxides are having. That is the point you should understand here. These are all having these basic natures and ionic natures, which are all having ionic natures. Ionic nature. These all oxides are ionic nature, but this only is covalent nature. The point is covalent character is nothing but there is that ionic nature is nothing but this produces ions in solutions, whereas in covalent is not having this. That cannot able to produce ions in solutions. This is the covalent. It is as like as organic compounds are having all organic compounds are covalent natures. Such a characters we can see in this case of beryllium due to its small size. What's the reason for this? The question which is asking. What's the reason for the covalent character of this beryllium? So due to its small size, while you are moving down the groups, the size will get increases. Size increases. While you are moving down the groups, the size will get increases. That's the point you should understand now. Next, we are going to study about the point what is here. The points, the size will get increases. Having these ionic natures. Then peroxide also you are very clear. Now we are going to study about these hydroxides. What are called as hydroxides? You know that. Hydroxides. Hydroxides. In this case of hydroxides, generally the hydroxides are nothing but MOH twice. That why we say it is that MOH twice is nothing but we can study it as beryllium hydroxide, calcium hydroxide, and strontium hydroxide, and barium hydroxide. These are all the hydroxides. The charge of OH minus is 1. So here it is 2 plus and 2 plus. 2 plus 2 plus charge. Now which is having 2 minus charge. Now this is that hydroxides. All hydroxides. Now in this hydroxide, while you are moving down the groups, that is that down the groups, barium hydroxides. This is that secondary families and its hydroxides. So now we are, which is that having less basic. And here this is one is less basic. This one is less basic. That is means beryllium hydroxide is that is less basic. All are more basic natures. All are more basic natures. So the basic nature is increases while you are moving down the groups. Basic nature, the basic characters increases while you are increases while you are moving down the groups. while you are moving down the groups, down the group, you please understand down the groups, the basic character is increases. Basic character is increases. And here sometimes just we can take it back. And also the basic character increases and solubility increases and thermal character increases. Solubility also increases. Where is the character? Solubility also increases while you are moving down the groups. So and also the thermal character also increases. Thermal character, that is a heat. Thermal characters. Thermal characters. This is all we get increases while you are moving down the groups. This is a point you should understand for this case of hydroxide. But especially the beryllium hydroxide, we can say it is amphoteric in natures. Amphoteric. Amphoteric in natures. What is amphoteric? Amphoteric means that it can react with that and it behaves as an acid and behaves as a base. That means which can react with that acid, which gives the product of that is beryllium hydroxide. Just you take it now acids. This react with this beryllium hydroxide is react with HCl. That means that you can write the equations. Beryllium hydroxide is reacted with a HCl, which is giving beryllium chloride and plus H2O. Whereas the same beryllium hydroxide is reacted with sodium hydroxide. Sodium hydroxide. This is also base. This is also base. But here it is reacting. Why? Because this is having amphoteric dual nature. Amphoteric is nothing but dual nature. Dual nature. Both acidic character and basic character is possessing same compounds. We can say amphoteric natures. Due to these amphoteric natures, this will give the product of beryllium hydroxide. That is, beryllium hydroxide react with the sodium hydroxide. Now you take the reaction. Beryllium hydroxide react with the sodium hydroxide. Now you take the reactions. You please take the reactions now. This is a point you can understand here. That is a beryllium hydroxide. React with this. This is the same beryllium hydroxide. BOH twice. It's react with it. So you react with this. What's the point here? The sodium hydroxide. The product form is called. We can write sodium berylate. That is a sodium berylate. Na2BO2 is called sodium berylate. Is a compound which is formed. Sodium berylate is forming along this liberation of two water molecules. Now the reactions which is taking place in this acid also, the reaction taking place in this base also. Now that is the reason we can say that is to be the beryllium. That is the reason the beryllium hydroxide is known as that is amphoteric in natures. The point is you should know these amphoteric natures. Next we are going to study about this. What are the halides? Which is the third point we are going to study about. What are halides? Halides are nothing but the halides. What are the halides? Halides. The halides are nothing but generally we can say that is secondary families of these halides. MX2. The MX2 is nothing but we have studied as beryllium chloride and magnesium chloride and calcium chloride and strontium chloride and barium chloride. This is the halides of all secondary families. In these halides, and here we are going to see the first of the series. The first of the series having covalent character. First of the series are having covalent character. The last, while we are moving down the groups, that covalent character is disappeared. That it is to be ionic characters. All the compounds which are belonging to these down the groups are having ionic characters. So all you can take calcium chloride. Now it can produce as a calcium 2 plus and Cl minus. That is 2Cl is there, 2 minus. So this is ionic characters. But we cannot see such a characters in this case of beryllium chloride. So now you see, and that's why we can say this is covalent in natures. That's a point you can understand. So here the halides of metal secondary families. The secondary families are nothing but we have studied as that is that beryllium, and here the magnesium, and here the calcium and strontium and barium. These are all the elements are belonging to the secondary family. The point you should understand. Now we are coming to know this is very clearly. And what's the point here is that covalent natures and aquatic. And what's the reason for? There is a question in your examination. There is a question in your examination. Why the beryllium showing covalent characters? Because of its small size. Because of its small size. So these are all the things we are going to study about in this chemical bonding. That is due to depolarization, and also this is due to it. And here the rules which was given by this. And here what's the reason for this? Covalent characters. And here there is the Fezans, the scientist whose name was why the compounds are to be covalent, why the compounds are to be ionic, according to Fezan's rule. According to Fezan's rule that we are going to study about. Now we are getting very clear about this. What's the reason? And here the beryllium is having this small in size. And especially we are going to study about this beryllium chloride. And here the point you should understand what is the characteristics of the beryllium chloride. We are going to study about especially about beryllium chloride. The beryllium chloride is covalent natures due to its small size. Is a small size, and also this beryllium 2+ we can represent as, which is hygroscopic natures. Hygroscopic natures. Hygroscopic natures. That is, hygroscopic is something that which can absorb the water even in a moist, even in a air, that it can absorb the water molecules, water even from this atmosphere, even from the atmosphere. The point you should understand, hygroscopic nature, which absorb that water moisture even in that present in atmosphere. That is hygroscopic natures. That's the point you should understand. Next, we are going to study about what is that which can fumes with fuming, and fumes with, that is that point you can write here, moist air. Moist air. This is a point you understand. Next to the beryllium chloride is having that there is that it can dissolve into organic solvents. This can dissolve into organic solvent. Dissolving. Why it is dissolving is possible with a organic solvent? Because of its covalent character. Covalent character. Due to the presence of covalent character, which is that dissolving in organic solvents. The point is, and you please know about what is here. And here there are that beryllium chloride can exhibit. This is a very important concept. You should understand, children, that beryllium chloride can exhibit in 3 molecular structures, 3 types of molecular structures. That beryllium chloride is to be in 3 types of molecular structure. That is given our book. One is called, we can say it is chain-like structure. One is called chain-like structure. Another one is called, that is dimer form. Dimer form. Another one is called monomers. Monomer form. Monomer. Monomer. Only single molecules. That you see, the monomer is nothing but it is beryllium chloride. Now write the structures. Beryllium chloride. There is a covalent bond. Chlorine is giving 1 electron in its outermost level. Barium is giving 1 electron in its outermost level. Chlorine is giving 1 electron in its outermost level. Beryllium is giving 1 electron. Now this is linear molecule whose angle is 180. So this molecule is linear molecule. This molecule is linear molecule. Now the point is, what is the dimer form? The beryllium to be dimerization at vapor state. This is at a high thermal. This is at there is to be the high temperatures. This monomer form is at a high temperatures. At a high temperatures. The monomer form is at a high temperature. But here the beryllium to be in the form of dimer state, that is Cl. You please understand this beryllium in the dimer form of beryllium. You please understand this. What is the dimer form of the beryllium? That is beryllium, chlorine. Then here to be that beryllium, and here to be that beryllium, and chlorine and chlorine. This is that point we should understand, dimer form. And here it is to be the beryllium. You please understand. This is the beryllium. This is a point you should write dimer form. And here it is a dimer form of this beryllium. You can write it as these structures. And this is to be, we can design as it is. This is the dimer form. We can write it as here. The dimer form of this beryllium. There you can see beryllium. There you can see beryllium. Two forms. That is two items. This is chlorine. This is chlorine. This beryllium having one more chlorine. And here this beryllium is having one more chlorine. This appears like dimer form. That's the point. This is that you see beryllium chloride. This is that you see beryllium chloride. That's the point. It's a dimer form. This to be exhibit only in vapor state. Vapor state. But here the chain-like structure is in solid state. Solid state. How this chain-like structure is possible, you see here. Already I have designed here. Beryllium, chlorine, beryllium, chlorine, beryllium, chlorine, beryllium, chlorine. This is that chlorine, chlorine, chlorine. This is chain structure. This is chain-like structures. Like structures. This is at a solid state. This is at a high temperature, monomers, high temperature. This is at a vapor state. Vapor state. This is a point you should understand now. Next, we are going to study about the concept. What is here with that? And here in this characteristics property of these all compounds, that you know the point what we have studied here. The point what we have studied here, all halides. So the beryllium is to be hygroscopic in nature. But here, all other compounds all to be in hydrated form. Hydrated form. How much of the water can absorb? Magnesium can absorb. Here it is 8H2O. This is hydrated state. Calcium can absorb 6H2O. And strontium can absorb 6H2O. And here barium can absorb 2H2O. This is the point. This is hydrated salt. Generally, that all are having hydrated forms. Hydrates form. This is a point. Not hydroxides. Hydrates are nothing but just it is to be absorbed at water molecules. When it is to be in the form of chlorine salt. Chlorine salt. When it is in the form of salt of chlorine. This is a point. Next we are going to study about what's the concept of oxoacids. What is the concept of salt of oxoacids? The point is salt of oxo. That is oxoacids. Acid, salt of oxoacid. That is nothing but the salt of oxoacids are nothing but if the salt which containing oxygen. That's the point we should write now. The salt which containing oxygen. What are the more atoms of like hydroxides are containing oxygen, sulfates are containing oxygen, and here that nitrates, nitrites, and nitrates all are containing, there is sulfates, oxalates, all are containing oxygen. So these are all the salt of oxalates, but especially we are going to study about and phosphate, calcium phosphate. Calcium phosphate is that is a fertilizer. You know that. These are all that concept we should understand here. This is that oxalate, phosphate, nitrates, nitrites, sulfates, hydroxides. These are all that salt of oxoacids. Now we are going to study about the magnesium. Generally, we are going to study about these carbonates. That is the point you should understand here. Carbonates also salts. Carbonates, metal carbonates. Generally, the metal carbonates are MCO3 for the secondary family. You should write now. This is nothing but we can design as beryllium carbonate, magnesium carbonate, and calcium carbonate. These are all the possible carbonates. Now we are going to study about the magnesium carbonates. That is, the magnesium carbonate is heated immediately that it forms magnesium oxide and carbon dioxide is liberated. The point is you should understand here. Now this is the things you want to know about. The carbonate solubility decreases while you are moving down the groups of this family. Solubility is decreasing. Solubility decreasing while you are moving down the groups. Why? Because the calcium carbonate is not soluble in water. Not soluble in water. It's not soluble in water. This is the point you should understand. While you are going down the groups, the solubility is decreases and thermal stability increases as we move down the groups, increasing this. What's the reason for this? Thermal stability increases. That means calcium carbonate is a stone that it can tolerate whatever means the heat we are giving to it, this carbonate. So thermal stability increases while you are moving down the groups. Thermal stability increases. Thermal stability. You see, thermal stability increasing. The point is the thermal stability increasing, whereas solubility decreasing. Dissolving ability in water. This solubility is nothing but dissolving ability in water. But your thermal stability is nothing but that is like how far this is tolerate while you are heating these substances. That's a point you should understand now. Next, we are going to study about and what's the reason for this is the question. It is asking what's the reason for its thermal stability? Just it is increases because of this cationic size is increasing. While you are moving down the groups, the cationic size will get increases. The thermal stability increases due to the increasing cationic size. Cationic size. What is cationic size? You know that cationic size. That means you are very clear with that. Beryllium is small in size, whereas magnesium, while you are moving down the groups, the size will get increases. That is calcium 2 plus and strontium 2 plus. These are all get increases while you are moving down the groups. This is a point you should understand here. Next, we are going to study about the concept. What is that concept we are going to study about? What's the point which is to be the thermal stability of this, how far it is increasing. This is also to be given on book as in a tabular column. And here that beryllium carbonate that it can decomposes even at 25 degrees Celsius. Whereas magnesium carbonate, you see, magnesium carbonate is decomposes at a 540 degrees Celsius. This is a point you should understand here. That is that while you are going down the groups, and here the decomposition also increases, and also there is a thermal stability also increases. That's the point you should understand. And here the decomposition temperatures. Beryllium carbonate decomposes at a 500 degrees Celsius. And here magnesium sulfate. Sorry, here it is at sulfates. Not this is carbonates, but here we are going to study about these sulfates. The sulfates and its sulfates and its next we are going to study about this. What is that? Nitrates, that you know all the nitrates, sulfates, all the sulfates, you know that. What are the sulfates? Beryllium sulfate and magnesium sulfate. And here this is that decompositions will get increases. For the decompositions, which is that decomposes at 500 degrees Celsius, which is decomposes 895 degrees Celsius. This is the point you should understand about these nitrates. And here nitrate also possible. What are the nitrates? What are the nitrates? You take now, this is what are the nitrates. And here the nitrates are beryllium nitrates. And here the nitrates are magnesium nitrates. And here the nitrates are, that is to be calcium nitrate, like you can go for calcium nitrates. Calcium nitrates. These are all the possible nitrates. These possible nitrates are we can prepare by these carbonates that you see. For example, you take magnesium carbonate and this treated with the nitric acid, dilute nitric acid. Now we'll get there is magnesium nitrate, NO3 twice plus CO2, this and all, 3 water, all get liberated. This is our aim. We are coming to know about what is called a nitrates. That is magnesium nitrate is forming. And here the decomposition is increasing. You know that point. What is that? Well, you are going down the groups and decreasing the tendency to form hydrates, increasing the size. And here decreasing, that means what is the point? You should understand. You take for example barium nitrate. You can take for example the barium nitrate, calcium nitrate, barium nitrate. This is the point you can write down. And here which is that nitrate is barium nitrate is anhydrous in state. Anhydrous in state. Anhydrous state. Anhydrous state. That means which is not absorbing the water moisture. Whereas these are all having anhydrous, hygroscopic nature, which can absorb the water molecules. Which can absorb the water molecules, water. But here it is anhydrous state. This is a point you should understand here. The point is here that next we are going to study about the point what is here. The next things we are going to study about. The point is next we are going to study about this what is the compounds of calcium. Finally, we are coming to know about what is magnesium carbonate. In this state, the magnesium carbonate. The magnesium carbonate. Magnesium carbonate. You come to know the magnesium carbonate. Sorry, magnesium nitrate. That it is to be absorbed these 6 water molecules. I told that very clearly. And first of the series is hydrated state. Last of the series, that is barium, is anhydrous state. This is hydrated state. Hydrated state. The point you should understand here. Next, we are going to see here what is the point? The compounds of calcium. We are going to study about what is that? Compounds of calcium. We are coming to know what is compounds of calcium. Compound of calcium. The point you should understand. Next, we are going to see compounds of calcium. Compounds of calcium. What are the compounds? I already have given calcium oxide, calcium hydroxide, and calcium sulfate, and calcium sulfate hemihydrate of H2O. This is plaster of Paris. This is gypsum. This is slacked lime. This is peak lime. You know the point. Now we are going to study about how this calcium oxide is prepared by laboratory methods. How this calcium is prepared by the laboratory methods. How this calcium prepared by laboratory methods. Vijay. Now we take here. Now we are coming to know how far this calcium oxide is called quicklime is prepared. You please understand. There is a diagrammatic representation as given in our book. You please take now. This is the diagrammatic representations. Now you take a limestone. You please take this point. What is limestone? The limestone is nothing but calcium carbonate. Calcium carbonate is limestone. Whereas calcium oxide is called a line. Quicklime. From this limestone, we have to prepare the quicklime. How it is possible? Now you have to pour this. The coal. Coal is nothing but it is a material as like us, or it is a wooden charcoal. Also to be, we can put it here inside this tower. It is fully covered by this iron tank. And here just you are pouring this limestone, that is calcium carbonate. Calcium carbonate you are taking here. And this calcium carbonate is all along with that calcium carbonate. You have to pour this coal. Coal is nothing but it's a carbon, pure carbon. Now this all together is to be melt and here heated. And here that it is to be, while you want to heat, there is an oxygen is essential. So we have to pass this oxygen current inside this tower. What will happen here? There should be a fuel, it was containing fuel. This fuel all together is goes inside this tower. And what will happen here in this process? The limestone is calcium carbonate is heated much at the temperature of 1070 to 1070 Kelvin to that is 1270 Kelvin temperature. This much of heat which is to be influencing in this tower. That is nothing but we can say. And here you have to pour these. What is that limestone and as well as there is a coal. This is a hooper. Hooper. You have to pour these all. Then it is to be there is a smelting process will take place or all to be smelt and all react together. And finally, what will be the product? Which is what is called, we can write calcium oxide and carbon dioxide is liberated. You see here, there is a liberation of carbon dioxide during this process. After the manufacturing of this calcium oxide, and what are the purpose we have to manufacture this calcium oxide? The calcium oxide is to be used in cement industry. The uses of calcium oxide. That is here, the line is out, is given there. Line is nothing but it's a calcium that is to be deposited, CaO. This deposited CaO is to be collected and used for many industrial purpose. The first industrial purpose is manufacturing of cement and also manufacturing of glass, manufacturing of glass industries, and also used in purification of sugar. Purification of sugar, sugar purification, that it is very essential. Sugar in sugar industries, and also it is used as a drying agent, which is used as a drying agent. These are all the points you should understand. Then we are going to study about what's the concept here. We are going to study about the point what is here, the calcium, and also the calcium and chemical properties. Some of that it is the physical properties we have studied here about this calcium, and some of the chemical properties we are going to study about this calcium. What are the chemical properties? Chemical properties of calcium. You take calcium oxide, that it dissolve into water. What will be the product? Calcium hydroxide is formed. It is called slacked line, which is called slacked line. The point you should understand. Now this is called slacked line. This is that used in many purposes of that is whitewashing and all many purposes which we are using, and designing and decorating homes and also and whitewashing of homes and also it is used in several fields. And here this is calcium oxide is reacted with the carbon dioxide, which is giving calcium carbonate. That is the reverse process we have seen. This calcium carbonate is heated at high temperatures. Calcium oxide and carbon dioxide is formed. The point we have studied already. Next we are going to study about the concept. What is the concept next year? We are going to study about the same calcium oxide is treated with that it is a many industrial preparations like steel industries and here many copper industries and copper manufacturing. In many fields we are using, there is a concept of what is the calcium. That calcium is reacted with it. The calcium oxide is to be react with that silica, SiO2. Now it is forming calcium silicate is in a slag, is formed even in copper extractions. So we have to use this calcium line in this case of copper extractions, in this case of iron extractions. In these all extraction, what should be that excrete? It is to be the waste material, it is to be the slag, which is to be forming. And during this extraction of metals like copper and iron, now this is that of forming. So this is to be used in this manufacturing of many and extraction of metals. The point you should understand. And here calcium oxide used in phosphorus pentoxide, that is P2O5, or you can write according to our book P4O10. Both are same. It's a dimer form, paper base. It is that P2O5. Now the product form is called calcium phosphate is forming Ca3PO4 twice. Calcium phosphate. The calcium phosphate is called, it is a fertilizer. It is a fertilizer. It is used in agricultural fields. It is a calcium phosphate. The phosphate fertilizers which are used in the field of agricultural science, you should understand here the point. Next we are going to study about. Next we are going to study about what is that? Slag line. How this slag line is forming. You know that point. What is slag line? It's nothing but slag line is nothing but calcium hydroxide. And here the calcium hydroxide, you have to take here that calcium hydroxide. Slag line, calcium hydroxide. This slag line is used in, and there is a white powder. Is how it is prepared, you know that, and it is uses calcium hydroxide is used as an, and here it is in a white powder. It is in a whitewashing powder. This white powder is used for the whitewashing of, and it is easily soluble in water, and it is to be easily soluble in water. It is soluble in water. And it is soluble in water, and also that's why it is soluble in water. That's why we are using to be that whitewashing. The point is, it is used for whitewashing. And here it is that point you should understand here. And here it is lime water. And also we can use for this testing of lime water milky. How this reaction takes place. Now we take for example, there you can take, there is to be the test tube which consists of there is to be calcium hydroxide, supposed to be lime water. You take now this lime water, and this lime water you are passing, there should be carbon dioxide gas. You are passing carbon dioxide gas. Immediately what will happen? This react with this and produces a precipitation. This precipitation is known as calcium carbonate precipitations. Calcium carbonate precipitations. How this chemical reaction is taking place? That calcium hydroxide is reacted with a carbon dioxide, which gives calcium carbonate, and then plus water is removed. And here calcium carbonate is in a stone is forming. This is has to be as the precipitator while you are passing carbon dioxide, current of carbon dioxide, passing into this lime water. This is known as lime water milky. We have studied in our lower classes. Lime water milky is formed. Lime water milky is formed. The point you should understand here. Next, we are going to study about the concept. What is here? In what are the fields that calcium hydroxide is used, and also how this calcium hydroxide is behaved. The calcium hydroxide is to be react with the chlorine. Calcium hydroxide is react with carbon dioxide. Now we take for example, the calcium hydroxide is react with calcium hydroxide. CaOH twice is react with the carbon dioxide in presence of water. The point is you should understand here. This will give this calcium bicarbonate. Calcium bicarbonate. One bicarbonate and its charge is 1 minus. 2 bicarbonate and charge is 2 minus. Now it is 2 plus. That is calcium bicarbonate. And also the calcium hydroxide is reacted with there is a chlorine. You know that it is a chlorine. Now the product formed is called, that is calcium chloride. Along with that calcium chloride, then it forms calcium oxychloride. It's called bleaching powder. It's called bleaching powder. It's called bleaching powders. Calcium oxychloride. This 4Cl carrying 1 minus. This 2 is carrying 2 minus. This is 2 charge, 2 plus. This is a point you should understand here. It is what is bleaching powder formations. And calcium hydroxide is used in the field of, already told it. What are the uses? Why we have to prepare this? This calcium hydroxide is used in, that is a bleaching materials and whitewashing, and it is used as a disinfectant. That is a bleaching powder is used as a disinfectant. So this all prepared from calcium hydroxide. So we can say this what it is building materials. Building materials. This is building material. And also it is used in this whitewashing purpose. Whitewashing purpose. And also it is used in this as a disinfectant. Disinfectant is used as a disinfectant is nothing but. Disinfectant is nothing but. It is a not to infect the germs in and around us, in and around our home. That is disinfectant. The point you should understand. This is disinfectant. Disinfectant. This is used as a disinfectant and whitewashing material, and is used for this whitewash, and it is used as a disinfectant, and also it is used in the manufacturing of bleaching powder, and also it is used in this purification of sugar. Purification of sugar in sugar industries. In sugar industries. Sugar industries. The point you should understand here. Next to the concept, we are going to study about what is gypsum. What is gypsum? You please take it now. The gypsum is nothing but gypsum. Next we are going to study about gypsum. The gypsum is nothing but this calcium sulfate 2H2. The points. What are the uses for the use of gypsum? Why is we can use? And here that it is used as uses of gypsum. It is used as a fertilizer, and it is used as an orthopedic costs, and also it is used as an that is causing of moles, and also it is used as an surgical fleets. It is a surgical fleets, and here this is a point you should understand here. And what are the uses of? And also it is used in Portland cements. Portland cements. It is also used as a Portland cements. And finally, we go for what are the uses of? This is how far we can prepare this plaster of Paris. You know that? How do we prepare this plaster of Paris? This plaster of Paris is nothing but CaSO4 dot hemihydrate, that is H2O, Now this is also used in many fields, but here that it is prepared from gypsum, that is CS4H2O, 2H2O, which is heated at high temperatures. Then it produces what is CaSO4 dot H2O, and this is heated much, that is like 393 Kelvin. The product which is formed is called calcium sulfate, you know that, and it is dead bond. This is known as calcium sulfate, is known as dead bonds, and dead bone plaster of Paris. Dead bone plaster of Paris. This is a point you should understand here. This is to be, we can write it as in this form of CSO4 of H2O is called plaster of Paris. This is nothing but we also said it as plaster of Paris. In this plaster of Paris, what are the uses? It is the point you should understand here. It is that used for this plastering purpose. That it is used for the plastering purpose. So that plasters. This is in plaster purpose, and also it is used in these bone fractions, and also it is used in these dentistry, and here it is used as cause the case shows. These are all the purpose we are manufacturing these. That is plaster of Paris. Next we are going to study about the simple concept in what are the biological importance of that secondary families. Biological importance. That is biological importance of secondary family. Biological importance of secondary family. That is especially that magnesium and calcium is very important for the human beings. The magnesium, which is that containing 25 grams in every human body. Every human body. And also calcium, which containing 1,200 grams in human body. You please understand. And also that it is the deficiency of magnesium. Deficiency of magnesium, which causes the disease, is known as convulsion. Convulsion is a disease. This has like as epilepsy. This has like as epilepsy. And also if there is a deficiency of calcium, the disease, and there will be that hormone deficiency, that name of hormones. The hormones is called a calcitonin. Calcitonin. This is that hormones, and also it needs to be and the disease which are caused by this deficiency of calcium. What are the disease? That is parathyroids. That is parathyroid. And there is a longer time taken for this blood clotting. Longer time for blood clots. The point we should understand. And also the magnesium is important for the photosynthesis. Photosynthesis. There are two types of chlorophyll, you know that. There are two types of chlorophylls. What are the two types of chlorophylls? That you know, one is chlorophyll A. Chlorophyll A and a chlorophyll B, which is that majorly containing of magnesium. So in biologically, it is very important, like this photosynthesis. The chlorophyll is the major part for the photosynthesis. This is the origin of photosynthesis, is only the origin of life. Origin of life. The point, we are very clear about this. Today, we have studied about these all secondary families and what are the oxides and peroxides, hydroxides, and chlorides and sulfate, and especially calcium, calcium hydroxide, calcium oxide, calcium carbonate, calcium sulfate, and what are the importance of biological importance. Everything we have completed, and next session we are going to see that. Next, there is a lesson, and the sir will going to teach on tomorrow. Thank you. Thank you, Julian. Listen, all 9:45, right?